Hi, welcome back. So today we will cover this particular variants of paper, S262, October, November 2024. So question 1, you have a random variable x with the distribution, 4, 5, 0, 0, 0, 0, 0, and then this. So use a Poisson distribution, so you can approximate this by multiplying n and p together. So this will then give you the Poisson distribution of parameter 4.5. So what you need to calculate is px greater or equals to 4. This is 1 minus px smaller than 4. So you have 1 minus px equals to 0, x equals to 1, x equals to 2, x equals to 3. So you can use the formula minus 4.5, 1 plus 4.5 plus 4.5 squared divided by 2. Then 4.5 cubed divided by 3 factorial. So do the calculation, you should get this value. Question 2, random sample of 50. And then you have 95% confidence interval. So you need to find the mean length. So what you can do is take 245,263 divided by 2. Should get 254 meter. That will be your answer. Calculate estimate of the standard deviation. So when you calculate it, you should get your sample standard deviation. Then you need to convert back to your population standard deviation. So you begin with something like this. So this has to be 0.95 because 95% confidence interval. In my video on this particular chapter, I've shown how to convert this particular form back into this. 263,254 divided by your your sample standard deviation minus 195. So if you don't know how to convert this, refer back to the previous video. So this particular value be 975. So this would be 1.96, or your sample standard deviation is 4.59. And then previously we also know that your sample standard deviation is your population standard deviation divided by the square root of n. So it means that your population standard deviation would be this. So you take 50 samples. So it is 32.5 meter. So it is given that the length of the root are normally distributed. Whether or not this will make any difference, answer will be no, because 50 sample is enough for you to use central limit theorem. So the reason is because the sample is approximately normal because of how big your sample size is, 50. So that's the reason. Question 3, you are given the distribution and then the p-value is 0.8. Check whether or not your p-value has increased. You need to use binomial distribution, carry out 10% significance level test. So X is binomially distributed. So your null hypothesis will be p equals to 0.8, and then your alternative hypothesis will be greater than 0.8, because this is a binomial distribution, and we take note that this is 23. So what we need to do is to find this probability. So if this is smaller than 0.1, then it means that you need to you have enough evidence to reject the claim. So you just calculate 23, 24, plus 25. So use the binomial distribution formula. Calculate all these three, you should get 0.0982, and this is smaller than 0.1. So there is enough evidence to reject the claim. To reject the null hypothesis. So it means that your P does increase. So given that there are 30 employees, comment on the suitability of the honest model. It will be not suitable because not all employees are tested. So remember that in this question, you want to test the number of employees who use factory canteen. So if this is originally 30 and you only use 25, of course your hypothesis testing will be skewed and it will not be suitable anymore. So that's the reason. Question 4. You have a population which is normally distributed. Mean is 35, standard deviation is 8.1. So you selected a sample of 140. So this will be normally distributed. The mean stays the same. Standard deviation will be 8.1 divided by square root of 140. So if you do the calculation, this will be the sample standard deviation. So I want to calculate Px bar greater than 36. Because you start from normal distribution, there is no continuity correction that you need to do. So this will be Pz greater than 36 minus 35 divided by 0.6846. So this is Pz greater than 1.461. Or this is 1 minus 0.928. Okay, so in my calculation, I skip one step. So you should be able to get this answer. Part B. Given that Px bar smaller than A is that, find the value of A. So you start with Pz smaller than A. minus 35 divided by that. This is 9x6. So you should be able to get I think is 2.197. Yep. So you read from the table. That should be 2.197. So A will be equals to 2.197 multiplied with 0.6846 plus 35. This will be 36.5. Question 5. You have a machine that puts sweets into bags. You have lemon and orange. They are given by Poisson distribution. So a bag of sweets is chosen by random. So find the probability that number of lemon is more than 2 but less than 5. So in this case, lemon is given by this. Let's say orange is given by this. So you want to find this, not more than 5, so you need to include 5. So you have L equals to 3, L equals to 4, and L equals to 5. So use the formula, calculate everything, it should be 545. Or I can write it down for you, so it's minus 3.7. So it's 3.7 cube power, power 3 divided by 3 factorial. 3.7 power 4 divided by 4 factorial, and 3.7 power 5 divided by 5 factorial. So calculate that, you should get 545. Find the probability that total lemon and orange is less than 4. So let's do the total, which is lemon plus orange, and this is the Poisson distribution. So you just sum those two parameters together, you should get 6.3. So you need to find the total less than 4. So you have t equals to 0, t equals to 1, t equals to 2, t equals to 3. So you have e to the power of minus 6.3. Yep, I did not calculate anything wrong here. So you start with 1, and then 6.3, 6.3 squared divided by 2, 6.3 cubed divided by 3 factorial. So the calculation should give you 126. So this is one bag. So now you have 10 bags. You need to use approximating distribution, so it's normal distribution. So total number of lemon is less than oranges. So when you calculate your probability, you should calculate lemon minus orange. So that's what we will do here. So for 10 bags, your lemon will be 37. Your orange will be 26. So if you convert them by approximating distribution, which is normal distribution, so your L would be normally distributed by 37, 37. For your O, that will be this. Oh, sorry, I just copied the both. 26, 26. So you need to compute L minus O. As I showed just now, lemon has to be less than oranges. So we will let this to be a new distribution called the difference. So it's L minus O, and this will be normally distributed by 37 minus 26. That's the mean. For variance, it will be 37 plus 37 plus 26. So that will be 63. Probably I can write down the final answer for your mean. That will be 11. Okay, so now we find D smaller than 0, and because this is from discrete random variable to continuous random variable, so be sure you do your continuity correction. So in this case it's less than 0, so it will be starting from minus 0.5. Okay, and then divide by the square root of 63. So if you perform this calculation, you should get minus 1.4489, and you change your, because your table cannot read that, so you need to change it. So try to find that value. That will be 1 minus 0.9264, and this is 736. So that will be your answer. Yep. Question 6. What are the constant A and B? So it will be the minimum and maximum, time taken to complete the challenge. Show that A equals to that. So what you need to do is to show that integrating from A to B, 1 over x squared is equals to 1. So the above integration will become minus 1 over x from A to B, and you have 1 over A minus 1 over B equals to 1. So you need to write A in terms of B, so B minus A divided by AB equals to 1. Do the simplification. You should be able to do this. So it shouldn't be that difficult. Given that your expected value is ln 3, show that B equals to 2. So your expected value should be x multiplied with 1 over x squared. So this will be equals to ln 3. And the one on the left will be integrating 1 over x, which you will get ln x, evaluating from A to B. So this will be ln B minus ln A. But we also know that A equals to B over B plus 1. So the one on the left, ln B minus ln B, and then okay, so basically you can combine them together. It will be ln B divided by B over B plus 1. So then this is just ln b plus 1 equals to ln 3 or b equals to 2. So let's move on to the next question. Find the median of x. So integrating from 2 over 3 until your median m, 1 over x squared dx is 0.5. Okay, so you perform the integration. You have minus 1 over x substituting the value 2 over 3 and then m inside. So this has to be equals to half. Okay, so you have minus 1 over m plus 3 over 2 equals to 1 over 2. So your m would be 1. Question 7, which is the last question. Height of a 1-year-old tree with certain variety are known to have mean 2.3 and carry out the hypothesis test 2% significance level. So probability that she will make a type 1 error. So it seems like this is a continuous random variable. So your type 1 error will be the same as your significance level, which is 0.02. You take a random sample 100, carry out the test at 2% significance level. Wait. So let's do it one by one. So first thing, you need to calculate what is your x bar. X bar will be 238 divided by 100, which is 2.38. Second thing, you need to calculate out the estimate for your standard deviation. So that is given by your S. So this is 580 divided by n minus 1, which is 99, minus 2.38 square times 100 divided by 99. Or alternatively speaking, you can write 238 squared divided by 100 and then multiply with 1 over 99. So those should give you the same thing. So this is 2.161. So after you have these two, you will need to carry out the 2% significance test. So your hash naught would be mean equals to 2.3, hash 1 mean slightly taller, so it's greater than 2.3. So now your sample is 2.38. So what you will need to test is this. If this particular probability is smaller than 0.02, then basically you will need to reject your null hypothesis. So the z-score will be 2.38 minus 2.3 divided by So this is a part where you need to be slightly careful, because S is your population standard deviation. You would need to wait. Okay. I think I wrote the wrong number. This is not 2.161 because there's a bit of, yep. This should be the value. 2.161 is the one at the bottom. My handwriting is a bit messy. So this should be 0.1370 divided by, you have 103. So this is your estimate of population standard deviation. So whereas the one at the bottom will be your sample standard deviation using the estimate of your population standard deviation. So you do the calculation. What you would get is, as I say, 2.161. So then you need to convert to something that you can read from the table. So this would give you this, and this is less than 0.02. So the conclusion is that there is enough evidence to reject your null hypothesis. It's just performing the test, right? Yep, carry out the test. Okay, part C. Scientists carry out the test correctly, but another one claims that she made a type 2 error. So what is the definition of type 2 error? Is that you have a false null hypothesis. So your null hypothesis is false, but being accepted. So this is a type 2 error. But from our test that we done previously, we rejected the claim, the null hypothesis. So therefore, this is impossible. Since we already rejected the null hypothesis. So that will be your answer for part C. Okay, that's all. Thank you.